In today's lesson, we will be doing average value of a function on an interval. In the first part of the lesson, we're just going to review real quick because what we're doing today is average value, which kind of sounds like average rate of change, but it's different. Average value has that word value in there, and we've done intermediate value theorem and mean value theorem. So just like a quick review of these three before we do today's lesson, so you can kind of keep it all straight. So first, the intermediate value theorem, remember, it has to be continuous. And then if you have the interval from A to B, it just says that there must exist a point, this y value, like all these y values exist in between A and B. In other words, so f of A, let's say, is 3, and f of B is 1, then all points in between that 1 and 3 must exist if the function is continuous on that interval. Average rate of change, that's your f of B minus f of A over B minus A. And that is when we are approximating kind of that rate of change is essentially before we were doing derivatives, that instantaneous rate of change, we would estimate it using average rate of change. And then the mean value theorem is when you have a function that's continuous and differentiable on an interval from A to B, and it just states that the instantaneous rate of change must equal the average rate of change at some point. So if you have the average rate of change from A to B, then some point on that interval, the instantaneous rate of change equals the average rate of change. Okay, and now to today's lesson, average value of a function. And it really is exactly how it sounds. If you have a function, and let's say we're looking on an interval from A to B, what is the average y value that appears on that interval? And we're going to use an integral to find it. So what it is 1 over the difference b minus a times the integral from a to b of our function with respect to x. So really all we're going to do is antiderivative, and it's a definite integral, so you evaluate on your intervals. And then at the end, you multiply by this 1 over the difference of b minus a. Okay, so for our first example, we're going to look at the function f of x equals 1 over x squared on the interval from 1 to 3. So there's my a and my b. So here we have the graph of that function, and we're just looking from 1 to 3, what is the average y value that exists on that function? So using that little formula we have above, we've got 1 over b minus a, so that's 3 minus 1, times the integral from 1 to 3 of our function with respect to x. So now I'm going to have 1 over 2, and now antiderivative, so let's think that's x to the negative 2, so we're going to add 1, x to the negative 1 divided by that power, and evaluate it from 1 to 3. So this right here, I'm just going to off to the side rewrite that as negative 1 over x. Okay, so now I've got the 1/2. I just have to remember, I think it's easy to forget to do that, but always remember that at the end. So when you evaluate, we're going to have negative 1 over 3 minus negative 1 over 1. So let's just simplify this down. 1/2 times negative 1/3. It's now going to be plus, I can write that as 3 over 3. So 1/2 times 2/3, 2/6, which is 1/3. So what we just found is a y value of 1/3. So that's going to be somewhere about here. And then sometimes you might be asked to now find what is the x value where the average value exists. So all we have to do is put the average value into our function. So 1/3 equals 1 over x squared, and now solve for x. We could just cross multiply, so x squared equals 3, so x equals, I guess, plus or minus the square root of 3, but we want on this interval from 1 to 3, so we really only want x equals the positive square root of 3. Okay, for the next example, I'm going to look at a function that's representing height of an object over time. So negative 16t squared plus 50t plus 5. And we're going to look at this function for the first 3 seconds. And then, let's see, we've got height, we'll say, is in feet, and time, which is in seconds. And we're going to do 2 different things. We're going to find the average height of this function and the average velocity. Well, this is a position function that is describing height. So to find the average height, what we're going to be finding is the average value. And then average velocity, that would be like taking the derivative, or in this case, we can do average rate of change for the first 3 seconds. Okay, so first average height. So we have 1 over b minus a. Well, in this case, if it's the first 3 seconds, it's from 0 to 3. So 3 minus 0 of the integral from 0 to 3 of our function with respect to t. So what I have is 1 over 3, and then I'm going to take the antiderivative. So I've got negative 16t to the third over 3 plus 50t squared over 2 plus 5t, and I have to evaluate it from 0 to 3. Okay, so 1/3, and then if I plug in 3 to the third is 27. And then I'll change this to 25 times 3 squared is 9 plus 5 times 3. And now if we plug in 0, we're just going to end up subtracting 0. And then I just did this on the calculator, so I've got 1/3 times 96, which equals 32. So the average height for the first 3 seconds is 32 feet. And now because we have a position function and they're asking average velocity, we can find the average rate of change from 0 to 3. So we'll look at h of 3 minus h of 0 over 3 minus 0. So let's see, I have 3 here. If I plug in 0, I'll get 5. And h of 3 ends up being 11. So 6 divided by 3, that's an easy one. 2, and then this is velocity, so this is feet per second. And that will sum up the video on the average value of a function. Good luck with the lesson.